In exercise 713, we're trying to see how the changing concentration affects the rate of an SN1 reaction. Now, we talked a little bit about the rate laws for SN2 and SN1 reactions in the video on understanding substitution reactions. And what we came up with was that the rate of an SN1 reaction only depends on the substrate. So the rate will equal K. That's just something to take into account the units, to make the units match, but really it just depends on the concentration of the substrate. And that's because the slowest step the rate limiting step is the loss of a leaving group, and that only involves the substrate for an SN1 reaction. So if you want to review on how we're getting that rate law, go back to that video on understanding substitution reactions. In this video, I just want to apply that. So we're going to use this rate law, and we're going to think about how changing the concentrations of different things affects that rate. Now we have two kind of characters here. We have our substrate, that's the tert butyl iodide, and then we have the chlorine, or the sodium chloride. Really, it's just the chlorine, but they might say sodium chloride, and that's referring to the nucleophile. Remember that whenever you want to see how a rate changes, always compare it to a case where everything is 1. And so here, let's color code this. We have our substrate in purple. And we have our nucleophile in blue. Notice the nucleophile does not affect the rate of an SN1 reaction. It's not part of the rate limiting step. So here they say, what happens to the rate if the concentration of tert butyl iodide, that's the substrate, is doubled? So it was 1, if it's doubled, now it's 2. And the concentration of sodium chloride, that's our nucleophile, is tripled. Well, there is no nucleophile in this rate equation. So it doesn't matter how much you change the concentration of sodium chloride, that won't change the rate. The rate will just be affected by the concentration of the substrate. And so in this example, the rate would double. So if we use that same process in this next one, we're comparing everything to a case where everything is 1. It says, what would happen to the rate if the concentration of tert butyl iodide, that's our substrate, remains the same? It was 1, it's still 1. And the concentration of sodium chloride, that's the nucleophile, is doubled. But notice in the rate law for an SN1 reaction, the nucleophile doesn't show up at all, and so it doesn't influence the rate. And the rate in this case would stay the same. It wouldn't change, because the rate for an SN1 reaction just depends on the loss of a leaving group. That's the rate limiting step, and that doesn't involve the nucleophile at all. It's only after the leaving group comes off in an SN1 reaction that the nucleophile plays a role. But that happens very fast. It's the loss of a leaving group that takes time. Only the substrate is involved in that, and so only the substrate is represented in the rate. Otherwise, thinking through this problem is very similar to thinking through the problem like this that we had for SN2 reactions. Write the rate law, just make sure you're writing the correct rate law for the mechanistic pathway. Compare everything to 1, and then plug in your numbers and see how they change. And that's how you can see how concentrations of the different reagents can predict the rate of the reaction. And this is also how you can figure out whether a reaction is happening through an SN2 or an SN1 mechanism in the laboratory. If the concentration of the nucleophile does not speed up the reaction, then it must be happening through an SN1 mechanism. If adding more nucleophile does speed up the mechanism, so the reaction, then it must be happening through an SN2 mechanism. Okay, so that's this exercise.